organizations like the International Maritime Organization and European Union are actively working to reduce shipping and port-related emissions, imposing sulfur oxide and nitrogen oxide limits, creating emission control areas, and promoting technological advancements. This places considerable pressure on both the shipping industry and seaports worldwide to comply. The MaritIEm project concentrated on developing a scalable model to reduce emissions in port cities, with applicability to other seaports. This required meticulous calculation of port-related transportation emissions and modeling diverse reduction scenarios. The overarching objective was to establish a data-driven methodology for managing emission reduction strategies, ultimately aiming to mitigate pollution from port activities. Except for a minor decline in 2020, the volume of containers handled at the world's largest seaports has consistently increased. The growing number of containers leads to an increase in the associated handling processes, and thus also to an increase in pollutant emissions. Furthermore, the majority of seaports are located in urban centers. Notably, the world's largest container ports are predominantly situated in megacities like Shanghai, Tokyo, New York, Los Angeles, etc., as well as densely populated cities with millions of residents. The interaction of these factors increases the concentration of emissions within and surrounding the ports. The project encompasses emitters categorized into three primary areas: seagoing vessels, terminals, and hinterland. Within the realm of seagoing vessels, analysis include container ships, cruise ships, and support traffic. Terminal investigations focus on vehicle and container handling equipment. Hinterland assessments involve the study of transportation via inland waterways, roads, and railways. This clip demonstrates the volumes of handled goods categorized by product type, including containers, vehicles, general cargo, or bulk goods. These volumes were meticulously analyzed and attributed to their corresponding hinterland connections. The analysis encompassed the movements of nearly 5,000 ocean-going vessels and approximately 500 inland vessels, alongside over 2 million vehicle transshipments and 1.1 million trucks for the year 2019. The modeling process involved not only determining routes taken but also considering the temporal distribution throughout the year, while accounting for specific constraints relevant to each mode of transportation, such as traffic flow. This modeling served as the foundation for subsequent dispersion calculations. The air pollutants and greenhouse gases emitted during transportation and the handling of goods not only have direct effects at their sources. The emitted substances are transported and in some cases undergo chemical and physical transformations. The concentration of these pollutants, whether directly emitted or formed through transformations, in any given location signifies the air pollution with these substances. This pollution adversely affects the environment and poses risks to human health. In order to reduce emissions from the port-related transportation examined in the MaritIEm project, various measures were identified and 3 scenarios implemented: the use of shore power for seagoing vessels, the electrification of van carriers at the terminals, and the use of fully electric trucks, serving the cities of Bremen and Bremerhaven. The second clip showcases the utilization of shore power systems, where the ship's engines are switched off while docked. An external shoreside power supply is now utilized. This necessitates the availability of a shore power system at the ship's berth, as well as the ship being equipped with a shore power connection. The scenario titled Electrification of Van Carriers explores the potential ramifications of transitioning van carriers to electric power within terminals. This shift from diesel-driven combustion engines to alternative propulsion technologies reduces the emission of air pollutants during transport. In this scenario, the adoption of battery electric trucks is assumed. Depending on data availability, the model could initially be implemented on a monthly basis, serving as a solid foundation for our overarching objective of eventually developing a real-time model to support sustainability monitoring in seaports. The 3-year-long research project MaritIEm is part of the Fund research initiative of the Federal Ministry of Transport and Digitally Infrastructure. The project was carried out by the Institute of Shipping Economics and Logistics in Bremen and IVU Umweltgym in Freiburg.